Okay, so when a rigid body undergoes only translation, all the particles of the body have the same acceleration. So the acceleration of our center of gravity is equal to our just regular acceleration for any particular point. And our angular acceleration is going to be equal to 0. And with that, the equation of motion become very, very simple. We don't have a moment around a centroid. We still have, some of the forces equals mass times acceleration. So this one goes back to our statics equation, and the rest stay dynamics. Now, as a note, that you can actually take the sum of the moments around any point you wish inside of that body. And so, yes, any other point would have a moment. If I chose right here, point F, or point P over here, the moment's going to be equal to the distance from that point to our center of gravity times the moment. Sorry, times the mass. I keep on wanting to say moment today. Now, what if I have a curvilinear translation? So the body itself is not translating. However, it is moving on a curved path. And that gives us a normal and a tangential component. So we break everything into components, and we get the sum of the forces in the normal direction is equal to the mass times our acceleration of gravity in the normal direction, and the same for the tangential. This is turning it, this is moving it forward. Some moments around our center of gravity is still going to be equal to 0. And if we have some point B that we care about, we're going to bring out something that's kind of like eccentricity, where we say, okay, we're a little ways away, and this is more or less just a cross product with the acceleration. We have two components. We have two components. One is the more or less tangential component of your position, and this is the normal vector, normal force. This is the more or less normal component, and this is the tangential force. So it's just a cross product right here, just written out nicely. So when you're solving these kind of problems, how are you going to do it? Well, first off, is it an XY or an NT coordinate system? And then try to figure out what direction the acceleration is going to go for the mass center. If you have a bunch of forces pointing that way, you know what? The acceleration is probably going that direction. Then you're going to draw a free body diagram and a kinetic diagram showing all the external forces. Figure out your unknowns and then apply your 3 equations of motion. You got either one set or the other. So you got this one or you got this one. And don't forget your angular acceleration equations in case you're trying to solve a problem that has rotation as well. And please, please, please don't forget that friction is always resisting motion. So whatever direction motion is going, friction is trying to push in the opposite direction. So that's it for this time. Thank you for listening, and I'll see you all later. Bye-bye.